So today's video we are going to see about TreeSet. TreeSet is one of the class we have in the set interface, and set interface is one of the interface we have in collection framework. So first, before moving to the TreeSet, we should discuss about what is set interface. Set interface is what is the unique features of set interface. Set interface which does not allow any duplicate elements, and it is not going to follow any order, which means it's unordered set. Okay, so like your mathematics set, the behaviors are like your mathematical set. So what are the classes we have under this set interfaces? We know that a linked has set, and tree set. We have sorted set also. Another sorted set. Sorted set is a class where we have a subclass like sorted set is an sub interface, and under that we have a tree set. Tree set is a one of the class we have under that's a sorted set interface. Okay, so now we'll move to that in detail about this tree set. So the tree set contains only unique elements. As I said, it's going to be have only unique elements, and it is access and retrieval is very fast and does not allow us a tree property, because we can have a we can separate a tree plus set. Tree set is nothing but tree plus set. So then what type of tree is nothing but one of the data structures. So then what type of tree can be implemented here is your binary search tree. So basically how the elements are going to be arranged in binary search tree, you know that you will be always have a tree. Then tree is nothing but you will be having a root node, then you will be having a left, and then you will be having a right. So this will be your left, root, right. So what about this binary search tree? You will be having the least element in the left side, that means small elements in the left side, and large elements in the right side, and the middle element will be the root element. So this will be your binary search tree. You will always go with the tree traverse is in the form of basic default one is left, root, and then right. So from this point itself you can able to understand the elements are going to be arranged in ascending order. That's the next point. So TreeSet class maintains ascending order. By default it's going to be arranging the elements in ascending order. It does not going to be follow any order for the insertion. And another very important thing is TreeSet does not allow any duplicate elements. Okay, so then it can be used, always going to be compare the generic elements with the help of the comparable interface. So next thing we are going to see about what are the constructors we have in TreeSet. First one is the default constructor. It's not going to be have any elements. It's going to be create a empty set. It's going to be create a empty set. So what is the next one is TreeSet. You can pass any collection as a parameter to this thread. So initially it will be empty. The empty is going to be merged with the collection which you have passed. So it's also going to be converted as a set, because in any other collections like list collections will have duplicates, but when you are going to be pass that any list elements, any list collection as a parameters, this can be as a parameter to this tree set. It removes the duplicates. It's going to be have a set form. Okay, the next one is basically it's going to be arranged. Next constructor is the TreeSet with comparator. So basically it's going to be arranging the elements in ascending order, but if you want to change if you want to change that in some other form like descending order, you can go with the comparative. You can incorporate or pass the comparator as one of the parameter to your tree set, which is going to be arranging the elements in a specified sorted format. Okay, then TreeSet, the sorted set. You can pass any sorted set element like S as a parameter to your tree set. So these are all the 4 types of constructors you have in tree set. Okay, Next we are going to see about the methods. We have some here we have listed only the few. Some of the methods we have in TreeSet are: first one is add method, which is used to add the element into the TreeSet, and next one is add all. It's used to already you have some empty set or any other set TreeSet. So if you're specifying any collection as a parameter in add all, that's going to be merged with the specified set. Okay, so and then sealing, it's very unique method we have in TreeSet. Sealing, it's going to be if you are specifying any element, like for example I have four elements in the list, like 2, 4, 6. By default, if you are inserting any elements into the set, it's going to be arrange the elements in ascending order. So 2, 4, 6, 8. My element is 6. If I am going to find ceiling of 6, so ceiling is going to be give you the equal or closest, greatest or highest number element of the specified element. So here 8 will be the closest greatest element. Otherwise, if it is not having any closest greatest elements, like if I am going to give 8, it is going to be written null. Okay, then comparator is one of the method we have. So it's used to arrange the elements in order. Specified order. It depends on your comparator. It's going to be arrange the elements in sorted order. Okay, and then descending iterator, basically as we said, one of the property of set is going to be arranging by default arranging the elements in ascending order. But if you want to make them in descending order, you can use this descending iterator method. So navigable set descending iterator also one of the navigable set is one of the class. We have a method descending set which makes the set as descending order, reverse order of the set. And floor, it's a reverse of ceiling. Actually it is going to be written equal or closest least element. In case if I am going to give 6 as my element, the closest least element is 4. So closest least among the least is 2, 4, 2 and 4. Closest least is 4. So if you want to find out floor, then you can, and that is the, if you want to find out the closest least element, then you can go for this floor value. Okay, then okay, then you have higher value headset. It's going to be have the same previous example headset. If I am going to specify 6 as my element, the headset is 2 and 4. The tail set is 8. Navigable headset also, it's going, you can specify the 2 and so it's a group of elements that are less than or equal to the specified elements. Inclusive, if inclusive, if true. Okay, then higher value, you know that higher value is nothing but it's going to be giving the closest greatest element of the specified element from the set. Lower value also, it's like high floor and ceiling. Iterator, it's you're going to be iterate the elements in ascending order. And pole first and pole last is the method. Pole first method is going to be extract, remove and retrieve the first element. In ascending order, it is the smallest element. Like as per our example, the 2 is the if you are using pole first is going to be retrieve and removes the first element. Pole last, it's going to be retrieve and removes the last element. Okay, then remove, basically if you want to remove any element, you can specify that element. Here there is no any specific index value you cannot pass, because it's not going to follow any insertion order. So you have to specify the element directly. You can specify the element in the remove method. And next one is a clear method. It's going to be clear the elements, clear the tree set. Clone it, if you want to make copy of this tree set, you can use that clone method. First it's going to be low returns the first element, which now is nothing but returns. It's going to be returns the first element. First element currently is in the sorted list. Last method, it's going to be return the last element, which means the maximum element from your set. And size by default, it's going to be give the number of elements available on your tree set. Okay, thank you.